Hey guys, welcome to 2018 Level 3 integration paper. So this video I'm just going to be covering question 1. So find the integral of 6x minus 8 divided by x cubed dx. Alright, so we're going to rewrite this. Okay, we don't like the x cubed at the on the denominator, so we're going to move it up to the numerator. So we're going to say rewrite this as integral of 6x minus 8x to the power of negative 3 dx. So now you just add 1 to the power and divide by the new power. So this becomes 3x squared minus plus let's see, add 1 to the power, divide by the power, plus 4x to the power negative 2 plus of c. So if we rewrite this, we can say 3x squared plus 4 divided by x squared plus c. And that's your achieved grade there. Solve the differential equation dy over dx equals to e to the power of 2x plus 1 over x, given that when x equals 1, y equals 2. So once again, we're going to integrate. So we're going to say y equals to... Alright, so the integral of 2x, okay, so you differentiate the power. So that differentiation of 2x is 2. So now we're going to divide everything by 2. So e to the power of 2x divided by 2 plus 1 over x divides... 1 over x differentiates... not differentiates. 1 over x integrates to ln of x. And we're going to don't forget the plus c at the end. So when x equals to 1, y equals to 2. So 2 equals to e to the power of 1 divided by 2 plus ln of 1 plus c. And if you solve this, you should get that your c value should be negative 1.69. So your function would be y equals to e to the power of 2x divided by 2 plus ln of x minus 1.69. And that's another achieved grade. Alright, find the integral of 2x minus 7 divided by x minus 5, the difference between 8 and 6. So now we're going to do a long division here. So we're going to do 2x minus 7 long division by x minus 5. That's because we have x on both the denominator and the numerator. So we want to get rid of the x entirely. So we're going to put a 2, and that's a minus. So 2x minus 10. Alright, so 2x minus 7 minus 2x minus 10. Double negative makes a positive. So that will become 3 here and 0. So that'll be 0 plus 3. And now we're gonna rewrite this. Okay, so now we can write our integral of 2 plus of 3 divided by x minus 5. And that's our integral. So now that will equal to 2x plus of 3 ln of x minus 5. Alright, so that should integrate to 2x plus 3 ln of x minus 5. And that is because the 2 will just integrate to 2x. Okay, that's pretty simple. But for the 3 divided by x minus 5, if you differentiate the denominator, if you differentiate x minus 5, that's 1. Notice that 3 is 3 times of 1, so therefore you have to add the 3 before the ln of x minus 5 in order to make the 3 at the numerator. Right, so that's our definite integral. And we're going to find the difference between 8 and 6, okay? So 2 times of 8 plus 3 ln of 3 minus 2 times of 6 plus 3 ln of 1. Alright, so once again, it's just based on some calculation works here, okay? So if you plug this one into a calculator, okay, so I'll just make sure this is right. So 3 minus 12 plus 3. Okay, that's right. So if you plug this into a calculator, you should get your answer as 7.296 as your final answer. And this is a merit question, and to get an achieved grade, you're looking for a correct integration. So up to here is an achieved grade. Alright, solve the differential equation dy over dx equals the cos of 2x over e to the power of y, given that y equals 0 when x equals the power of 4. Alright, so in this equation we have y and x on the same side. Because we have two very different variables, we don't want the two different variables, we want to get rid of them, one on both sides. So we're going to cross multiply. So this will become dy e to the power of y dy equals to cos of 2x dx. And now we're going to integrate both sides. Okay, so we're going to say the integral of e to the power of y dy equals to the integral of cos of 2x dx. Alright, so the integral of, that's equals to here. So that equals to. So the integral of e to the power of y is just e to the power of y. Okay, the differentiation of y is just 1. E to the power of y divided by 1 is still e to the power of y. So e to the power of y equals 2. So we're going to integrate the right side here. So cos should integrate back to sine. Okay, so that should be sine of something. However, if you differentiate this in a function here, if you differentiate, you'll get 2. So you have to divide sine x by 2. So that will become e to the power of y equals to 1/2 of sine of 2x. And do not forget the plus c at the end there. The plus c on the x side, okay? The plus c is not on the y side. The plus c is always on the x side, okay? So now we can solve when y equals to 0, x equals to when y equals to 0, x equals to pi over 4. So e to the power of 0, that's just 1. So we just say 1 equals to 1/2 of sine of 2 pi over 4 plus c. And you should get your answer as c equals to 1/2. So therefore, you should get your, it's just a, when you get up to here, it's just a matter of using your calculator correctly. So you just plug everything into your calculator and you solve for c. So therefore, your final equation is, I was asking you to solve. So you can just say that e to the power of y equals to 1/2 of sine 2x plus 1/2. You can just leave your answer like this and you'll get a merit grade. To get an achieved grade, you're looking for a correct integration. So up to here, that's an achieved. Alright, last question. The diagram below shows the graph of the function f of x equals to 1/2 of e to the power of x minus 1. The point Q, KK, lies on the curve. The shaded region in the diagram is bounded by the curve. The x-axis and the line x equals to k. Show that the shaded region has an area of 1/2 of k. Okay, so once again, we have a function. We need to go to the area function. So that we mean we have to integrate. So we have our f of x. We're going to rewrite this as 1/2 of e to the power of x minus 1/2. And we need to find the integral of this. Okay, that's pretty straightforward. So integral of 1/2 of e to the power of x minus 1/2 dx. Alright, so 1/2 of e to the power of x, if you differentiate that, you'll still just get 1/2 e to the power of x, okay? Because the differentiation of x is just 1. 1/2 of e to the power of x divided by 1 is still just 1/2 of e to the power of x. So 1/2 of e to the power of x minus 1/2 of x. That equals to. It's a definite integral, so we don't need our plus c at the end. So the point KK lies on the curve. So show that the shaded region has an area of 1/2 of k. Alright, so you see this point. Okay, this point starts at 0 and this point ends at k. So therefore, you can know that the 1/2 of e to the power of x minus 1/2 of x, k and 0, that should give you your answer. Okay, that'll give us something we need to find out. It should come out to be 1/2 of k, but we need to prove that. Okay, so 1/2 of e to the power of k minus 1/2 of k minus 1/2 of e to the power of 0 minus 0. So that's just gone. Sorry guys, the last video got cut off, so I'm just going to continue back from when the video cut off. So it just cut off at about here when we're trying to figure out what our value is. So we should get our answer as this becomes 1/2 of e to the power of k minus 1/2 of k minus e to the power of 0 is just 1, so minus 1/2. That equals to our area. Okay, so right now it seems to be a little bit hard to to solve, okay? But one thing we do know, is when k equals to k, when x equals to k, our y value is also k. So therefore, we're going to substitute k and k into our equation. So k k equals to 1/2 of e to the power of k minus 1/2. So if we move the 1/2 to the other side, so k plus 1/2 equals to 1/2 e to the power of k. So we have 1/2 e to the power of k here, and that is equal to k plus 1/2. So we can get rid of this and replace it with k plus 1/2. So k plus 1/2 minus 1/2 of k minus 1/2 equals to a. Alright, so this plus 1/2 and this minus 1/2 cancel each other out. So k minus 1/2 of k, that equals to area. Therefore, area equals to 1/2 of k, which is the correct answer here. Getting all the way to the bottom here, that gets you an excellence grade. To get a merit grade, you're looking for a correct integration and in terms of k. Area in terms of k, so getting up to here correct would probably get you a merit. To get an achieved, you're looking for a correct integration. So getting up to here, it's an achieved. Alright, thank you for watching this video. I'm sorry how the video got cut off midway, but nonetheless, I hope you still enjoyed. I hope to see you all in the next one. Thank you, bye.